unit. So a unit vector is a vector whose magnitude is 1. And there are some unit vectors that are very important, and it's the ones that correspond with the positive x, y, and z axis. And if you're in 2 space, it would just be x and y. But for this, if I come out 1 unit and put a dot, and I have my position vector, that's a unit vector. I'm going to grab something that might show up a little bit better. Here's the unit vector on the y-axis and a unit vector on the z. What are those terminal points? What about this first one? What's that? That's 1, 0, 0. And on the y-axis, that's 0, 1, 0. And on the z-axis, 0, 0, 1. So I can say 1, 0, 0 is a unit vector that in position form is on the positive x-axis. And the length is 1 unit. And similarly for zero, 1, 0 and 0, 0, 1. But this one's on the y-axis, positive y, and length is 1 unit. This is on positive z. Now we give these special names. Have y'all had this in physics? I, J, K. The standard basis vectors. So vector I, and you could use a little hat right there. Vector I is vector 1, 0, 0. And if you're in 2 space, you would just leave off that last component. Vector J is vector 0, 1, 0. And vector K is 0, 0, 1. They're called the standard basis vectors. When we throw this in, you can do this. So if I have vector 2, 5, negative 3 in component form, I can write this as 2 times vector I plus 5 times vector J minus 3 times vector K. They are the exact same thing. So if I see a problem written like this in the book, I might write it in angle brackets for the first step to work the problem out. So there's one more thing in this section, and it's about a unit vector in the same direction of A. So let's throw this in here real quick. To find a unit vector in the same direction as a vector A, here's what we do. We'll call it U for unit vector. It's vector A divided by the magnitude of vector A. And I'll work an example like that for you tomorrow.